everyone. JSConf EU 2017, this 6th of May, there will be coding. There will be lots of coding. And then suddenly, Abraham Lincoln and Jacob Gzip show up. And what is this even a bunch of encoding about? We'll find out. Will we find out? Will that happen? Who knows? There will be images, lots of images. What are these images even about? Will she explain? Hopefully she will explain. But let's see. There will be waiting. Lots of waiting. In this season, hottest Codebuster. Codebuster, get it, get it, get it? Knock, knock. Who's there? File compression. Talk. This is a talk, right? I hope this is talk. File. Compression. Hey, everyone. My name is Irina. I write code over at Scripto. And today, I'll be talking about compression. When I start off on preparing talks, I kind of go into this research mode, and I read a bunch of papers about stuff. So I was reading certain papers on compression, kind of minifying your code and being faster on the internet. And I came across this quote. Rules of JavaScript are extending far beyond XML and HTML DOM manipulation, which I thought was super cute to find in a paper. But yeah, so a bunch of people kind of came up and said, you know what, we do so much JavaScript, and JavaScript takes up so much of our space on the internet, if you think of the internet as taking up space. So yeah, we're writing a ton of JavaScript. And in fact, by using compression, we're saving about 50% of all that JavaScript traffic. So that's why I wanted to talk about compression. I know I lured you in here by Phil Collins, but we won't actually do any Phil Collins. It's just HTTP compression. I'm really sorry. So what is compression? Compression, you start off with a file that, for example, index HTML will look something like this. Right? You compress it, and hopefully it works. Compress it, compress it, compress it. And then at some point, you end up with a much smaller output. So if you were to cat the compressed file, kind of looks a little bit wonkier, much more different than the first one we kind of had to begin with. Cool. And a bunch of that, if you think about it, if it happens over an HTTP, what you have is you have a client and a server communicating with one another, and you want to kind of pass in certain information from one to the other. So what client does is it says, OK, I'm going to accept some types of compression, and these will be these. And that all goes under accept encoding header. When the client sends in its request. And what the server does is says, OK, cool, I'm reading that through, but I'll send it to you based on whatever you can accept. So if the client says, I'll do Deflate, Gzip, and Brotli, your server will send in whatever it is feels like it's necessary. But what are all these names? They're a little bit confusing. So I think we should let's work through these as we go through the talk. So if you were to actually look into your headers and stuff like that in your console, you can see that the accept encoding could be seen through the request headers, and then if you were to look at the response headers, they're just the same, and that's what the page sends you back. Funnily, this is also from accept encoding page on MDN. Cool. So a lot of these compression things started off with something called Deflate. And that's kind of the basic algorithm that most of these will use, so things like Gzip and Brotli. But Deflate is a basis of two, Huffman and LZ77. And these are kind of compression algorithms that take in a bunch of data and see whether or not it's similar in one way or another, and look at the distances between similar codings. I won't talk too much about Huffman and LZ77 because it's a little bit boring. So I have a bunch of sketch notes on those two in particular, so you can look at those later. But I'll talk about Deflate because Deflate is a basis for everything else to begin with. So Deflate's used quite quite primarily with PNGs and Gzip. And those are the ones we're kind of used to seeing to begin with. What it is it's a stream of blocks. So all of these compression things are streams. With Deflate, stream of blocks, that each block is individually made up of 3 different bits. And the first one is the one that indicates whether or not there will be more data coming through in your stream of data. So 1 means, OK, we're actually kind of done here, so we can close out that stream. And 0 means that there will be more stuff coming in, so it's binary. The second bit, it passes on the actual raw data and passes in the static Huffman blocks, so the ones I talked about that I won't actually mention as much. But static Huffman blocks. And the rest of it is a little bit more dynamic, so it's the dynamic Huffman blocks and the table that kind of references all the other ones to themselves. And there's like a little bit that you don't touch. So that's kind of what a single individual Deflate block looks like. Awesome. And so the mention that I will do with LZ77 and Huffman is the fact that a compression works with the pointers, and the pointers are the ones that are handled by the LZ77. And when we talk about weighted symbols, and when we talk about symbols in general, and how these are a lot more than just a letter A, it has a lot more meaning to it, that would be handled by Huffman. So that's Deflate. And all of these other ones are bases of that. Cool. And then the one that we hear a lot more about than actual Deflate is Gzip compression. And those are the ones that most of the content on the internet is actually moved through. So Gzip is kind of cool. And an implementation of that that's probably the most used software library out there, maybe after like MySQL8, is zlib. And zlib is the one that actually has a Node implementation. That's the one we'll talk about in a bit. So with zlib, what you get is you get a little bit more control over processing and memory usage. That means that you can create a trade-off as to whether or not you want a more compressed content or you want it to be faster. And that's kind of how you get around it. And it comes with 3 different levels that you can do to create that kind of compression. So on level 1 or level 0, you actually don't do any compression, but on level 9, you are able to compress content a lot further, and you're able to go back further in your static blocks to copy content over and pass it through. So what would be cool is if we do a little bit of work with zlib. So I mostly write Node, and so zlib is it's a built-in API in Node. So what I want to do is actually, let's work through it and see what we can do in terms of compressing content as we serve our files over to the client. So let's actually do that. Awesome. So I kind of started us off. Yeah, there is a lull in case I forget file. So I started us off with having an HTTP. We'll have FS because we want to create a stream when we serve stuff over. And I've started us off with actually having a server, and it'll listen on 8080. Cool. So when I was mentioning previously, what the client does is it says, I'm going to accept certain types of encoding. And based on those types of encoding, we should be able to work with certain types of data. So I said we'll be working with zlib. So actually, let's get zlib in here. And we'll be using streams. So I'm just going to require pump. And pump is a non-broken version of pipe. Whoops. Did I say that out loud? I was just getting filmed. Cool. So what we'll want to be able to do is we want to have a source. So this will be our stream. So we'll have a read stream that takes in our index HTML, and I should have an index HTML in here. Cool. And what we want to be able to do is, based on this accept header that we get, we want to do different types of content. So this would be a basic match for Gzip, and I will get syntax in a bit because I forgot. So we'll be working with either Gzip or Deflate. Now we'll actually copy the matches over because that's a little bit easier. And then based on that particular match that is Deflate, I want to be able to create a Deflate compressed file. And what pum does is it takes your source and it handles your operation, handles your output, which is the response. And I also have a handler that does the error handling for us. And then what else I want is just like to be able to make sure that whatever is the response that comes out is fine. So our content encoding here is, I'm stuck. Oh, I'm on a different keyboard, I'm sorry. Persian is not gonna work in Vim. Neither will Russian, okay, sorry. Cool, so I'll copy these over as well as we go a little bit faster. And then if we have a gzip kind of content, we will then do the same thing. zlib has a gzip implementation. Node's zlib will always have a gzip implementation, but so does Node's API of it. And we'll do the same thing, pump it over. OK, awesome. So let's actually test this out, because we want to be able to see whether the content will actually get. So let's start up a Node server. And what we want to do is we want to be able to curl the command. And we need to pass in headers, because that's what basically we're looking at. So the headers is accept encoding. And that would be gzip. Let's start off with gzip and localhost 8080. And I've done this literally every time the command is header. Yeah. Funny story, my trackpad stopped working yesterday. OK, we'll type it out again. And we'll actually get the information right away to actually be able to see this. So header is accept encoding, and it's gzip again, and localhost 8080. Cool. That actually did not get zipped. That's not cool. But what we can see is it's going through OK. Well, at least we get the file back. So let's get back to our editor. So that should be lowercased is the issue. And if we go back, no, that's still not working. Cool. Yeah, probably a good idea. Ah, cool. And what would be kind of interesting to see here is actually how much space this takes. So what we can do is, oh, you can't see the bottom. Cool. That would be important. I think my keyboard also stopped working. So what we also want to do is maybe just see some output. Okay. We'll silence everything else, and then we'll still pass it in the header, which is accept. Coding, Gzip. And then what we'll do is we'll pipe it over and just look at the word count, which is 235 with Deflate. I'm going to minus this a bit, and just for a second. And then what else we want to do is compare it to what a Deflate output would look like instead, and kind of do the same thing. So it'll also compress, but the word count should be a little bit different, which is 305. So Gzip just is smaller than what a Deflate compatible thing is, which is kind of interesting. So that was kind of like the zlib example I wanted to show you, which is neat. And then let's look at other methods that you could use. So we looked at like 305 Deflate, 235 Gzip, just so you keep those in mind. Cool. Another one I wanted to talk about is Brotli. Brotli's been, I think, out in the wild for about a year or two. So it's a fairly new kind of way of compressing. And what it does, it specifically was made to handle HTTP compression. So it's made specifically for web development, which is kind of cool. So if we look into, like, go back to this stream of blocks that Deflate does, what Deflate has is a single block has like the literals, if you don't think about it in the bits that I was talking about before. It has the literals, and it has the length and the distance, so like the pointers and then the weighted symbols. That's Deflate. And what Brotli is a single block is actually a set of commands, if you can see the bottom. So instead of just actually these interpretations, it's a set of commands. And what it has is insert, copy, distance, and actual insert literals. And what's interesting about this is that normally weighted symbols have a dictionary that you only insert while working in a specific window. But what you can do with Brotli is you can go back further at any point in time instead of just in a specific sliding window and apply that dictionary, which makes for a much smaller compressed file, which is neat. But it also comes with a dictionary of commonly used HTML terms, which is, again, specifically made for HTTP compression, so it makes for a much smaller file. But at its base, I mean, you can tweak it and things like that, but at its base, it's much slower, and you have to wait a little bit longer for the compression to happen. So a lot of the times, it gets used with static content rather than doing it on the fly. And what I wanted to show you now is actually being able to use this library I found called Brotli backwards, because I can't pronounce that. And actually, so you should be able to see the difference kind of between the two things. OK, so let's start up another file. And what we'll need is kind of the same deal. Let's just copy it over. We won't need zlib, and I'll just call it compress. OK, Brotli backwards. no. We'll still use pump, and we'll still use fs. And we'll still do it on the fly rather than actually compressing files, static files, just so you see the difference. OK, let's not worry about the headers. We'll still need a source. Let's not worry about having these. What we'll have is then, instead of having compress, we'll create a stream with the Brotli stuff. I think it's create stream. Ah, maybe that is correct. It's called this Brotli. Brotli create stream. Awesome. And let's again start up a server. Yeah. And let's look at, I mean, the compressed file is going to look the same. I kind of just want to look at what the word count is like. So we'll do the same thing. We kind of don't need to send in headers, I think, but it doesn't matter. And also look at the word count. Oh, well, the word count didn't work. Create stream is not a function. OK. There's a bunch of different methods, so you can do async and synchronous, but I like the stream stuff. So, oh, it's compress stream, not create stream. Cool. That would make sense. You're compressing. OK. And we're going to need a server again, which is like 148. It's like half the size, which is neat. Yeah, so there's that. And that's how Brotli works. It's super neat to actually, I think, I think it's super neat to be able to work with something that's more static. So you're probably going to have a ton of images. You're probably going to have a ton of static assets you want to be able to share. And if they're taking up a bunch of your space, it's neat to be able to use something like Brotli. And most major browsers will accept it. Actually, all the big four, the big four, I think, are all on board with Brotli. So Edge, Firefox, the big three, and Chrome are all accepting. I'm not sure about Safari. So you'll have that. And then when you're working with your usual kind of bundles of JavaScript and CSS, working with something like Gzip, if you're not already doing that, you would be. Yeah, so we went through the example. So I wanted to be able to kind of show you what it is like to kind of work with HTTP compression. I hope you learned something about zlib, and I hope you get to use it in your day-to-day work. Thanks.